Good morning. I'm Kavitha, Assistant Professor in Mathematics from H&S Department. Today I'm discussing about triple integrals. The triple integral is evaluated as integral of x1 to x2, integral of y1 to y2, integral of z1 to z2, f of x comma y comma z dx dy dz. Integral of x1 to x2, integral of y1 is in terms of x and y2 is in terms of also x, and z is in terms of x and y, z in terms of x and y. Then function is in terms of f of x comma y comma z. Then you are integrating it is a triple integral, then dz dy dx. So what you have to do there here, integration with respect to, first you need to integrate with respect to z, then y, then x at last. Means integration is what, first with respect to, here z in terms of x and y. So z in terms of x and y, that's why you need to integrate with respect to z. Then your y is in terms of x, that's why you need to integrate with respect to y. Then your x is numerical values, your x, what is your x, limits are numerical values, then integrate with respect to x. So means your first you need to integrate, observe here it is in terms of, your limits are in terms of x or y, x or y. So first you need to observe your in limits are in terms of x or y. So z1 of xy, z2 of xy, first integrate with respect to z, then x, then y, then x, dz dy dx. So note here, if when x1 x2 y1 y2 z1 z2 are all constant, means it is not only numerical values, then the triple integral can be evaluated in any order. Triple integral can be evaluated in any order, then you'll get the answer same. If you're integrating with respect to x y z, whatever, if you want you can integrate with respect to z first, then y, then x. Otherwise x first, y first, then z. This is the order of the integration based on your interest. Okay, now you will solve the one problem based on the triple integrals. So based on this triple integral, so evaluation of, evaluate triple integral of integration of 0 to 1, 1 to 2, 2 to 3, x y z dz dx dy dx dy dz. So what you have to first, it is a numerical values, observe here. What is that? Here is a numerical values. What are the limits here? Observe here. Here 1 0 to 1, 1 to 2, 2 to 3. Then these all are numerical values and constant. Then you can, as your wish, if you want to integrate with respect to z, y or x, based on that, first I'll integrate with respect to, then x, first integrate with respect to x. First integrate with respect to x, then what you will get here, integration of x, x square by 2. Apply the limits. What are the limits? 2 to 3. So upper limit is 3 and lower limit is 2. So then integrate with respect to dx, then you'll get, apply the limits, then you'll get n 9 by 2 minus 4 by 2 dy dz dy dz. Then apply limits afterwards, what you'll get, 5 by 2. 5 by 2 is a constant, then write in front of this f 5 by 2, integration of 0 to 1 z into y square by 2, again integrate with respect to y, then integrate with respect to y, then you again you are getting y, integration is y square by 2. Limits are 1 to 2, limits are 1 to 2. Then what you will get the value of, if apply limits of y, then you will get the value of that is 3 by 2. Then again what is the last integration, that is with respect to z. Again if you will get integration with respect to z, then what you will get here, z square by 2. Apply the limits, Z square by 2 limits are 0 to 1. Then at last you'll multiply this 5 by 2 into 3 by 2 into 1 by 2, then you'll get the answer 15 by 2. Means if your numerical values are given in your question, means constants, then as a if you want to integrate, here I am integrating only with respect to x, but you want to integrate with respect to y or z or x based on your interest. Okay, then you'll get the same answer. 15 by 8 is the answer. Then one more problem is there. Uh, this is what evaluate integral of 0 to a, integral of 0 to x, integral of 0 to x plus y, e power x plus y plus z dx dy dz. So dx dy dz. Then what is that integration? Integral of 0 to a, integral of 0 to x, integral of 0 to x plus y. So e power x plus y is a function in terms of x y z, but limits are what is the limits here? Observe here, limits are 0 to x plus y, 0 to x, 0 to a. Observe your limits are in terms of x plus y, means limits in terms of x and y. That's why you need to integrate with respect to z. Then your again your limits is what? X. Your limits is x. Then again what is the numerical values? Constants is there. So that's why you need to integrate first with respect to z, then y, then x based on limits. Observe the limits. If limits are in terms of x and y, you need to integrate with respect to z. If your limits are in terms of x, you need to integrate with respect to y, then at last with respect to x. So 0 to a, integration of 0 to a, integration of 0. So I am integrating with respect to z. So what is the z? Integration of e power x. You know the integration of e power x always e power x. So e power x plus y plus z, e power x plus y plus z. Then apply the limits here, 0 to x plus y. So e power x plus y, in place of z, you need to apply x plus y minus e power x plus y dx dy. So you apply the limits, after you'll get 2 into x plus y. Why? Because here x plus y is 2 times repeated. That's why you're getting 2 into x plus y. E power x plus y dx dy. Then e power 2x plus y by 2. Again, you need to integrate with respect to y. Why? Because your limits are in terms of x. That's why you need to integrate with respect to y. So integral of e power 2 into x plus y by 2. Why you will get e power x plus y by 2? Because your integration of e power x is e power x. But here 2 is there. That's why e2 into e power 2 into x plus y by 2 minus e power x plus y. Apply the limits 0 to x, where you need to apply these limits in place of y. So what you will get here, e power 4x by 2 minus e power 2x. Again lower limit. Anyway, in place of y, if you apply limit 0, then you will get e power 2x by 2 plus e power x dx. Again, simplify this, then you will get the answer for this. Again, your integration part function is in terms of completely in terms of x. That's why you need to integrate. At last you'll get dx. So that's why integrate with respect to x. So integrate with respect to x. At last answer is what? E power 4x by e power 4x. E power 4x is integration. Again, you need to differentiate with respect to 4x. 4x differentiation is 4 divided by 2. Then you'll get 2 into 4. E power 3, 2x. 2x differentiation is what? 2x difference. E power 2x integration is e power 2x. Again, you need to differentiate this. So e power 2x by 2, that is 2 into 2 plus e power x, 0 to a. E power 4a, apply the limits. E power 4a by 8 minus 3 e power 2a by 4 plus e power a minus of 1 by 8 minus 3 by 4 plus 1. Why you are getting this is means in 0, if you are apply e power 0 is 1, that's you get e power, what you'll get here, e power 4x. In place of x, if you apply 0, then what you'll get, minus 1 by 8 minus 3 minus of 5, because here minus is there, lower limit is there, 1 by 8 minus 3 by 4 plus 1. Then you'll get the answer, e power 4a by 8 minus 3 e power 2a by 4 plus e power a minus 3 by 2. 3 by 8 is the answer for that particular integral, triple integral. So this is the how to solve the integration. Triple integral is the numerical, not numerical values. Variables are there. How to solve the triple? Here some more problems are there. Then in polar form, how will you find the polar form? Polar form, you know that polar forms are what is integral of 0 to pi by 2? Integral of 0 to a sine theta, integral of 0 to a square minus r square by 2 r dz dr d theta. These, it is called polar form. You know that x equal to r cos theta, y equal to r sine theta. So integral of 0 to pi by 2. Here what you have to write here, first what is there, x equal to r cos theta, y equal to r sine theta, y equal to r sine theta, x equal to r cos theta, y equal to r sine theta. These two are called polar forms. Polar forms. Then it is r. Then apply the limits, 0 to pi by 2, integral of 0 to a sine theta, r integral of, then separate, first integrate. Why? Because you need to integrate with respect to dz. You are in terms of limits, observe here, limits are in terms of a square minus r square by 2. Means what is the limits are in terms numerical values and r is there. That's why you need to integrate with respect to z. Here observe, what is the limits for this a sine theta, means in terms of theta. So that's why you need to integrate with respect to r. Then at last 0 to pi by 2, then you'll get the all values in terms of theta. That's why you need to integrate with respect to theta. So integral of 0 to pi by 2, integral of 0 to a sine theta, or integral of 0 to a square minus r square by 2 dz dr d theta. So these are the, this is the question. First you need to integrate with respect to z. So integral of 0 to a square minus r square by 2 dz dr d theta. Then 0 to pi by 2, integral of 0 to a sine theta r z 0 to a square minus r square dr d theta. Integral of 0 to pi by 2, integral of, so first what is 0 to pi by 2, next 0 to a sine theta r, integral of z, apply the limits. What are the limits here? Observe, integration of dz, you will get here only z, you will get, apply the limits, 0 to a square minus r square by 2, then dr d theta. So what you will get here, a square minus r square by 2, apply the limits, you will get only, this is lower limit is anyway, that is 0. That's why you are getting a square minus r square by 2. So dr d theta. Then take out the common 1 by 2, then you'll get the integral of 0 to pi by 2, integral of 0 to a sine theta. Then apply the limits a square r minus r cube dr d theta. So again integrate with respect to r, with respect to r. Then what you'll get, again integrate with respect to r, then you'll get a square. Integration is r square by 2. R cube integration is r to the power of 4 by 4. Integral of 0 to a sine theta. Apply the limits. Integral of a square into a square sine square theta by 2 minus a power 4 sine power 4 theta by 4 d theta. So apply the limits, then what you'll get here, apply a power 4, take out common a power 4, already 1 by 2 is there, then take out common only a power 4 by 2, then you'll get integral of 0 to pi by 2 sine square theta d theta minus a power 4 8 0 to pi by 2 sine power 4 theta d theta. So what is here 0 to pi by 2? After that, you will get in terms of all, you need to integrate with respect to theta. What are the limits for that theta 0 to pi by 2? 0 to pi by 2. So here a square sine square theta sine power 4 theta d theta you will get. You know the value of one formula is there. What is that formula? Integral of 0 to pi by 2 sine power 4x dx. If n is even, one formula is there. If either it is sine or cos, in between the limits 0 to pi by 2, 0 to pi by 2 sine power 4x dx, 0 to pi by 2 cos power nx dx, n minus 1 into n minus 3 into n minus 5, n into n minus 2, n minus 4 into pi by 2 if n is even. This is the formula. So based using this formula, what you have to do there, here apply this formula, then you'll get a power 4 by 4 1 by 2 into pi by 2 minus a power 4 by 8 to 3 by 4 into 1 by 2 into pi by 2 is the answer. Then at last what you'll get, the answer for this 5 by a power 4 by 128 is the answer for this problem. So this problem is called, it is based on polar coordinate. You know the polar coordinates are x equal to r cos theta, y equal to r sin theta. X equal to r cos theta, y equal to r sin theta, using these polar coordinate. This is the polar coordinates. So, okay. Next problem. Here what is given? Evaluate triple integral of volume problem is there. Triple integral, actually you know that why you are using triple integral means it is a volume. So xy plus yz plus zx dx dy dz, where v is the region of the space bounded by x equal to 0, x equal to 1, x equal to 0, y equal to 2, z equal to 0, z equal to 3. So limits is given in question. That's why first what you have to do there, triple integral of xy plus yz plus zx dx dy dz. So integration of 0 to 3, 0 to 2, 0 to 1, xy or f of x comma y comma z is xy plus y plus yz plus zx dx dy dz. Then apply the limits. First you need to integrate is like numerical values, all constants. Your integration limits are constants. Observe here, limits are constant. Then integrate with respect to any. If you want, you can integrate with respect to x, integrating with respect to y, with respect to z, but I am using here x with respect to x. So what you are doing here, x square by 2 into y, then integration of, I am integrating with respect to x. That's why what you are getting here, x square by 2 into y plus xyz. Why? Because yz is there, you are integrating with respect to x. So you'll get xyz plus zx square by 2. Then 0 to apply the limits dy dz. After applying the limits, what you will get, y by 2 plus yz plus z by 2 dy dz. So then again integrating with respect to y. Again integrating with respect to y, what you are getting here, y square by 4 plus y square by 2 into z plus z by 2 into y. Why? Because y is there. No, what is the integration of y? Y square by 2. Here also y is there, y square by 2. Then z by 2 is there. Only dy integration is y. Apply the limits 0 to 2. 0 to 2. Then, so after simplification, what you will get here? Y square by 2. Then you will get only z 1 plus 2z plus z dz. So integration of 0 to, again integrating with respect to 1 plus 3z plus dz. So here 2 plus 3 by 2. Overall answer is 33 by 2 is the answer. First you need to integrate with respect to. Then one more problem is there. What is that problem? Here, evaluate triple integral of xyz. Evaluate triple integral of xyz dx dy dz over the positive octant of the sphere. Sphere equation is given and radius is 1. What is the sphere here? Radius u a is the radius of that sphere. Sphere is what? X square plus y square plus z square equal to a square. Then z is what? Z equal to under root of a square minus x square minus y square. So it is given, what is this? Is a f of x comma y comma z over the positive octant of the sphere. The projection of the sphere on the xy plane, positive octant. Positive octant means it is on xy plane. So what is that? Xy plane on is the circle. Then if it is positive octant, what is the xy plane? What will happen if it is xy plane? Then equation is what you will get, z equal to 0. What is the equation of xy plane? Xy plane means you'll get here z equal to 0. If you apply in the sphere equation, what you'll get here, in place of z square you'll get 0. That's why you'll get only x square plus y square plus equal to a square. Then this is the circle with radius a. The circle is covered as y varies from, what is here, y varies from 0 to under root of a square minus x square. X varies from 0 to 1. Y varies from 0 to under root of a square minus x square. The y varies from 0 to a. Then triple integral x y z dx dy dz. Dx dy dz. So here observe, what is that? X varies from, y varies from 0 to under root of a square minus x square. Why? Because your sphere in positive octant. Positive octant on xy plane. Xy plane means z axis equal to 0. If you apply z equal to 0, then what you will get? X square plus y square equal to a square. Circle equation. So circle equation is your radius is a. So y is varies from 0 to under root of a square minus x square. X varies from 0 to a. Then function is x, y, z, dx, dy, dz. So integral of 0 to x dx, integral of 0 to under root of a square minus x square y dy, integral of 0 to under root of x square minus x square y square z. So what is that? First integrating with respect to, so then I am integrating with respect to z, then y, then x. That's why here integrating with respect to x. With respect to x, sorry, with respect to z. Integrating with respect to z. So what is the integration of z square by 2? You will get 0 to under root of a square minus x square minus y square. Integration of 0 to y. Then apply the limits in place of z. What you will get here, a square minus x square minus y square by 2. Then next one is what? After apply the limits, what you'll get? Y a square minus x square y minus y cube minus y cube dy. So then all in terms of y. So integrate with respect to y. Apply the limits. What are the limits? Y limits are under root of a square minus x square. 0 to under root of a square minus x square. 1 by 2. Then apply y square minus y square a square by 2 minus x square y square by 2 minus y power 4 Apply the limits, then what you'll get? A square minus x square by 2. So a square minus x square minus whole square, a square minus x square whole square by 2. Then 1 by 4, 0 to a x into a square x square whole square dx. So here use a minus b whole square formula. Then apply here. Integrate with respect to x. Integrate with respect to x. So integration of 0 to a x into a square minus x square whole square by 2. After integration 1 by 8 integral of 0 to a x a power 4 minus 2 a square x cube plus x to the power of 5 dx. This is the after simplification of integrating with respect to y and apply the limits. So you'll get x to the power of a power 4 minus 2 a square x cube plus x power 5 dx. So what you'll get here? Integration of this x square a power 4 by 2 minus 2a square x power 4 by 4 x power 6 by 6. Then overall answer is what? After applying limits, then you'll get a power 6 by 4 by 8, 48. A power 6 by 48. So many problems. Evaluate the integral here. What is there? Integrals of 0 to 1 y to 1 0 to 1 minus x x dz dx dy. Here one more problem is there. What is that problem? First you need to integrate with respect to, here observe here, what are the this question, observe what is there. 1 minus x is there, so 1 minus x means you need to integrate with respect to, x, x in terms of x is there, so integrate with respect to z, then with respect to x, at last y. Observe here, what are the limits here? 1 minus x is there, so integrate with respect to z, then x, then z, y, at last y. What are the limits? Integral of 0 to 1 minus x, integral of y to 1 0 to 1. So based on the, here one more problem is there. Here it is for based on polar coordinates, minus h to h, 0 to b, 0 to 2 pi, z square plus r square sin square theta dz dr d theta. So integral of first integration with respect to what is there? At last theta you need to integrate with respect to theta. Here first you need to integrate with respect to z, then r, then theta. So here observe what is the integrations first with respect to z, then y, then x. Here also same, e power x with respect to z, with respect to y, at last x. Based on that, using all these are the problems of multiple integrals.